Hello and welcome to Mr. Tompkins EdTech and my series of walkthroughs for the AQA GCSE Mathematics past papers. This particular video is November 2017, Paper 1, Foundation Tier. Now, with the new specification being new, Grade 9 to 1 past papers are like gold dust, and you should not be watching this video unless you've already attempted the paper yourself under test-like conditions. If you haven't, stop the video now and go and do it first. I'm serious, go. Still watching? That's great. Why not subscribe to my channel so you can easily find it again the next time you want some help with your maths. I have plenty of A-level content too, so make sure you come back and check that out if you're carrying on with your maths next year. Please hit the like button if you found the walkthrough helpful. This really helps out my channel and it makes it much easier for others to wade through all the YouTube dross and find the good stuff. Also, before attempting the actual past papers, make sure you've gone through all the practice sets first. AQA produced 4 sets of practice papers to help students prepare for the new GCSE exams, and I would advise you to work through these before moving on to the actual past papers. Have a look at this video series which gives full walkthroughs for AQA practice sets 1 to 4. If you don't happen to have a copy yourself, you'll find a download link to the practice paper in the description below each video. Finally, feel free to ask questions below. It would be helpful if you include a question number and be as specific as possible. I really appreciate your comments and feedback, and I try to respond to these as quickly as I can, especially around exam times. Okay, let's get into it. Welcome along to another past paper walkthrough for Mr. Tompkins EdTech. Today we're going to be looking at GCSE Mathematics from AQA. This is Foundation Tier Paper 1, and this paper was originally set in November of 2017. While we're talking about November, I'm going to quickly announce the winner of my November giveaway. I was giving away a calculator this month. If you entered the competition, you had a good chance of winning. But there was only one winner, and that winner was the Gaming Myth 07. So a shout out to you. Congratulations, your calculator will be coming to you soon. I hope you enjoy it and keep watching. So let's get on to question 1. Circle the decimal which has the same value as 3/5. Now decimals are simply fractions over multiples of 10, hundreds, thousands. So let's rewrite this as a fraction over 10 instead. So 5 times 2 is 10, so multiplying the top by 2 as well, we should get 3/5 is equal to 6/10, and 6/10 is 0.6 as a decimal, so that is the correct answer. Question 2. How many millimeters are there in 7.5 centimeters? Well, hopefully you know that 1 centimeter is equivalent to 10 millimeters. So 7.5 centimeters is going to be 7.5 times 10, or 75 millimeters. So that one there. Question 3. Which of these shapes has 2 lines of symmetry? Circle your answer. Now there's no pictures for any of these. I would suggest you draw them. So a semicircle is half a circle, just need to be sketches really. A rhombus is a pushed over square. A trapezium is 1 pair of parallel sides, and an isosceles triangle looks like that. Okay, so which of these shapes has 2 lines of symmetry? Now a semicircle only has 1 down there. A rhombus has 2 lines of symmetry. A trapezium may have 1 if it is an isosceles trapezium, but we weren't told that. So it could have 1, or it might not even have any at all. And an isosceles triangle has 1 as well down the middle. So the only one really that has 2 is the rhombus. Question 4. Circle the number that is 7 less than -12. So that is -12, subtract another 7. So if you're at -12 on the number line, so here's 0, here's -12, somewhere down here. then subtracting is going further down the number line, isn't it? So if I go 7 jumps further down the number line, I'm going to end up at negative 19. That one. Question 5. Solve x minus 3 is equal to 14. So we've got a linear equation, x, that we need to solve. You can either add 3 to both sides, that's one way of thinking about it, or you can change sides, change sides. Either way, you're going to end up with x equals 14 plus 3, or x equals 17 as the solution. 5b wants us to solve 5y is equal to 45. Again, if I divide both sides by 5, 5y divided by y, 5 is y, and 45 divided by 5 is 9. So that gives me a solution of y equals 9. Finally, I've got solve 8 plus w equals 6. Now, I can either subtract 8 from both sides, that's one way of thinking about it, or I can take that 8, move over the equal side, change sides, change signs. Either way, I'm going to end up with w equals 6 subtract 8. Now, lots of students make mistakes with this because they just read that as 8 subtract 6 and write down the answer 2. It isn't, it's 6 subtract 8. We're taking away more than we've got, haven't we? So we're going to end up with a negative number. So w equals 6 subtract 8 is negative 2. Question 6a. Work out 9,174 divided by 11. Now, paper 1 is the non-calculator paper, so we're going to have to use a non-calculator approach here. Normally, I would suggest one-digit division, use short division, and if you've got 2 or more digits, then use long division. 11 is 2 digits, but it's only a little bit above 1 digit, so probably we can get away with doing short division here still. So 9174 divided by 11. So 11's into 9 don't go. 11's into 91. Well, 11 times table is 11, 22, 33, 44, 55, 66, 77, 88, 99. So that is 1, 2, 3, 4, 5, 6, 7, 8 times, isn't it? Goes in 8 times. So how many times it goes in? Goes up here. 91 subtract 88 gives me a remainder of 3. So I'm going to write a little 3 in there. Next, we're going to look at how many times 11 goes into 37. I can see I've already done the maths down the right-hand side here. I can see it goes in 3 times. 3 11s, let's just write that in blue. So 3 11s is 33. So the difference between 33 and 37, or the remainder, is 4. So I'm going to carry that 4 over to the next digit and start over. How many times does 11 go into 44? Well, 11 goes into 44 4 times. Remainder 0 because 4 11s are 44. So our answer is 834 exactly. (6b) Work out 5/6 plus 3/7. Okay, we've got fraction addition here. Now you notice my denominators are different. So if we want to add these fractions together, the first thing we need to do is find a common denominator of 6 and 7. You're always going to get one by multiplying the two together. 6 times 7 is 42. There is sometimes a smaller number that is a common multiple of both, but in this case there aren't. 42 is the smallest number that 6 and 7 both go into. Now 6 goes into 42 7 times, so multiplying this one by 7 gives me 7 5s are 35. And then 7 goes into 42 6 times, so multiplying this one by 6 as well, I'm going to get 18. So that is equal to 35 plus 18 over 42. So 35 plus 18 is 45, 53, 53. So 53 over 42. Now normally that would be a perfectly acceptable answer. There's no problem writing things down as improper fractions. It's just that in this particular case they're asking you to write it as a mixed number. So that means I need to write it as with a whole number part. So we need to ask, how many times does 42 go into 53? It goes into 53 once, and the remainder, 53 subtract 42, is 11. So we're going to write that as 1 and 11 over 42. Question 7. The diagram shows the scores given by judges during a television show. And in the graph we can see that the scores are between 0 and 5, except no one's actually given a score of 0, and the frequencies of those scores have been given are up the side. Okay, now the first question is, which score was the mode? Now a mode is the most frequently occurring. So having a look at our graph, mode is going to be the tallest bar on the graph, which is quite clearly that one there. That's the tallest bar, and that is for a score of 4. So the score of 4 occurs 9 times. Now the fact it occurs 9 times makes it the mode, but the score itself is the modal value, so the score is 4. Right, now we're told there were 4 judges. Each judge gave 1 score in each round. How many rounds were there? Okay, so from the graph we can work out what the total number of marks awarded or scores awarded by adding all the different frequencies together. So this first line has got a height of 3, this one has got a height of 6, and then 6, and then 9, and then 4. Now if we add all those numbers together, we'll find out how many scores were given all together. So 3 plus 6 plus 6 plus 6 plus 9 plus 4. So let's just write that down. So total scores given is 3 plus 6 plus 6 plus 9 plus 4, wasn't it? And that adds up to 3, so it's 12, 21, 25, 28. So it adds up to 28. So we were told there were 4 judges, so each judge is going to have awarded a quarter of that then, aren't they? So number of rounds is going to be those 28 scores divided by the 4 judges, and 28 divided by 4 is 7. So 7 rounds. Question 8. A library book was due to be returned on the 27th of September. It was actually returned on the 14th of October. There is a fine of 8p for every 1 day the book is late. Work out the total fine. Okay, now in order to answer this question, you need to know how many days in each month. Do you remember those? There is a little rhyme, isn't there? It says 30 days to have September, April, June and November, etc., etc. So you might remember that rhyme, or there's a trick that you can do with your knuckles that you might have been shown. So that also works, but either way you need to know that September has 30 days. Okay, so if it should have been returned on the 27th and it wasn't, that means it was late on the 28th, the 29th and the 30th. So there were 3 days in September. That the book was overdue. And it was also overdue for 14 days. So it was returned on the October the 14th. Yeah, so it's still overdue by 14 days in October. Okay, so adding those together, it was overdue a total of 17 days. And if they're charging you 8p for every day, you need to work out what 17 times 8 is. So 7 8s are 56, and 1 8 is 8 plus 5 is 13, so that's 136p, isn't it? So what was the total fine? It's going to be £1.36. Question 9. In a game, 3 stars are hidden at random. Each star is behind a different square on this board. And we've got a grid with 5 by 5 squares, or 25 squares in total. Now we're told that a square is chosen at random. What is the probability that the star is behind it? Okay, so like I say, there are 25 squares in total, and the answer, or the stars, are going to be behind 3 of them. Now you should know that probability is defined as being successful outcomes divided by total outcomes. Now in this case, there are 25 outcomes in total that you could pick. You can pick any one of those 25 squares, and 3 of those would be winning squares. So the probability that there's a star behind it is just simply 3 out of 25. Now in part B it says, in one game the stars behind 3. In one game the stars are behind 3 consecutive squares. The squares are in one row or in one column. One of the squares is in E2. Write down all the possible pairs of the other 2 squares. Okay, so we know that there's one star in E2. Okay, so there's definitely one there. Now, if they're in consecutive, that means they're all in a row. So they could be there, like that. So that's one possibility. So they could be in C2 and D2. Or they might be this way. In which case they would be in E3 and E4. Now they could also, I suppose, be like that, couldn't they? So they could be in E1 and E3. And I think that's the only other possibility, isn't there? That's the 3 different possibilities that they can be. So let's just write all those down in the answer box. So what do we need to write down? Write down all the possible pairs of the other 2 squares. So we said that it was C2, D2. So it can be C2 and D2. Let's put a plus for them because it's both of those 2. That's the pair. Or maybe we can put them in brackets. That might be better. So if I write them down, C2, D2 is one pair. And then my next pair is E3, E4. E3, E4. And my last possibility was E1 and E3. Question 10. Complete the table to show equivalent fractions and percentages. Okay, so I've got a half, and we already know that that's 50%. Then I want to pair up 3/10 with its equivalent percentage. Well, I know that 3/10 is the same thing as 30 over 100, just by multiplying top and bottom by a factor of 10. And so that means that 30 over 100 is 30%, because a percent is just out of 100. So 43%, that's going to be the same thing as 43 over 100. Does that cancel down? Well, even if it does or it doesn't tell us to cancel it down. I'm just tempted to leave it like that. And then finally 5 halves. So that's a top heavy fraction, isn't it? So that's the same thing. It's how many times does 2 go into 5? It goes in twice, remainder 1. So that's 2 in 1/2, which is the same thing as 2.5, or 2.50. That's the same thing as 250%, isn't it? As a decimal, as in as a percentage. 11a. Cards in a pack are red or blue in the ratio of red to blue is 2 to 3. What fraction of the cards are red? Circle your answer. Well, if they're in the ratio of 2 to 3, then there are 2 parts red and 3 parts blue, which means altogether there are 2 plus 3, there are 5 parts. Okay, so then that means that the fraction of that are red are 2/5 and the fraction that are blue are 3/5. Okay, so what fraction of the cards are red? It's that one there, isn't it? 2/5, that one. Okay, 11b, a different pack has 72 cards. 5/9 are yellow. Work out the number of yellow cards. So we want to find 5/9 of 72. So when we're finding a fraction of a number like that, we need to divide through by this number on the bottom and then times through by the number on the top. So I'm going to do that as 2 separate steps. So I tend to do the division first because that gives me smaller numbers to deal with. So 9s into 72 I know go 8 times. 8 9s are 72. So that's the same thing as 5 times 8. And 5 times 8 is 40. So my answer is 40. Question 12. How many edges are there on a square-based pyramid? Circle your answer. Now, any shape and space question they give you, which is just wording, I highly recommend that you draw a quick sketch or diagram to go with it. So a square-based pyramid is like a square with a point on the top, isn't it? That all the points then join up to. Okay, so how many edges are there? How many straight lines did I just draw? I drew 1, 2, 3, 4, 5, 6, 7, 8. There are 8 edges altogether. So it's that one there. Okay, 12b, how many faces of a triangular prism are triangles? Okay, again, there's no diagram here, so let's quickly sketch. Now, a triangular prism is like a Toblerone, isn't it? So you get a triangle at the front and then some straight lines and a matching triangle at the back. So how many of those faces are triangles? Well, you've got the front one, haven't you? That's a triangle, and the back one. And that's it. You've got 3 other faces, but they're all rectangles. So how many faces of a triangular prism are triangles? There are 2. Question 13. A bus can be early, on time, or it can be late. Now, the probability that the bus is early is 0.1. The probability that the bus is on time is 0.6. And work out the probability that the bus is late. Okay, so we had 3 choices then, didn't we? We can have that it is early, on time, or late. And we are told that the probability of it being early is 0.1. And the probability that it's on time is 0.6. And we need to work out what this one is here. Okay? Now, these are all 3 possibilities that there are. There aren't any others. There aren't any others than those, are there? So, using the rule of completion, which means that all of your possible outcomes must add up to 1, those 3 amounts must add up to 1. So 0.1 plus the 0.6 plus the probability that it's late add up to 1, which means that the probability that it is late is going to be 1 subtract those other 2. So 0.1 plus 0.6. So 0.1 plus 0.6 is 0.7, and 1 subtract 0.7 is 0.3. So that's my answer, 0.3. Question 14. On the grid below, draw the graph of x plus y equals 2 for the values of x from -3 to 3. Okay, so we need to work out our coordinates so we can plot this graph. Okay, now the easiest way to do that is to create a table of values. So pulling up a ruler, let's make a little table for our x values and our y values. Okay, so we know that this range goes from -3 to 3. Now you need a minimum of 3 points, but there's no harm in doing it a few more. So -3, -2, -1, 0, 1, 2, 3. Massively overkill. Probably only need 3 or 4. But anyway, it's not a very difficult question. So x plus y equals 2. That means y is going to be 2 subtract the value of x, rearranging that for y. So we can find the y value by taking the x value away from 2. So if x is 3, then y is going to be 2 minus 3. 2 minus 3 is -1. If x is 2, then y is 2 minus 2 is 0. If x is 2, then y is 2 subtract 1, which is 1. If x is 0, then y is 2 subtract 0, which is 2. If x is -1, then y is 2 subtract -1. 2 subtract -1 is the same as 2 plus 1, which is 3. I think you can see the pattern going on here. It's going to be 4 and 5, isn't it? Okay, so I've got -3, 5 to plot. -3, 5. -2, 4. -1, 3. 0 goes with 2. 1 goes with 1. 2 goes with 0. And 3 goes with -1. And notice they're all in a nice straight line. It was a linear function, so you'd expect it to be in a straight line. If it wasn't a straight line, you should be asking yourself some questions. Okay, so now they are all in a nice straight line. Let's pull in up a ruler and let's join them up. Now your line should stretch the full width of your graph. Shouldn't start and stop with the first point. The graph does continue in either directions, so your graph should show that. Okay, so there's my line. Question 15. 5% of a number is 31. 1% of the same number is 6.2. Work out 13% of the number. Okay. Well, I can make 13% from 2 of my 5% values plus 3 of my 1% values. 2 5s are 10, 3 1s are 3, and 10 and 3 makes 13. So if I can take my 5% value, which is 31, and sub that in, so 2 lots of 31 plus my 1% value, which was 6.2, sub into there, 3 lots of 6.2, and then add those together, I get my 13%. So 2 lots of 31 is 62. 3 lots of 6.2. Well, 3 6s are 18 and 3.2s are 0.6. So that's going to give me 18.6. And 62 plus 18.6 then. Now if it's helpful to do that as a column addition, 18.6. So 0 and 6 is 6. 2 and 8 make 0, carry 1, and that's going to give me 8, isn't it? 80.6. So the answer is 80.6, and that is my 13% of the number then, 80.6. Question 16. Complete the grid so that when you multiply the 3 numbers in any column, row, or diagonal, the answer is 1. So if you look at this bit here, look, 2 times 1/20th is 2/20ths, and 2/20ths is the same thing as 1/10, and 1/10 times 10 is 1. So that diagonal already multiplies together to give you 1. So we've got 2 out of the 3 pieces along here, so a 20th and times 20 is 1. So that means I have to have a 1 in the middle here to make that true. And it's the same along this diagonal here. 2 times a half is already 1, so that means the middle one must be 1 to make that true as well. So once I know the middle one, then it should be fairly easy to work out the rest. So then this one, what do I have to multiply 5 by to get 1? I have to multiply it by 1/5. And what do I have to multiply 10 by to get 1? Looking along this diagonal here, that needs to be 1/10. Okay, so half times 20 is 10 as well, times 1/10 gives me 1. That works in that direction as well. So we're done. Question 17. A sequence has 3 terms. The term-to-term rule for the sequence is multiply by 8 and then add 11. The first term of the sequence is -1. Work out the third term. Okay, so I know that the first term is -1. Now the second term is going to be the first term -1 multiplied by 8, and then we're going to add on 11, aren't we? So -1 times 8 is -8, and -8 plus 11 is going to take me to +3. So my second term is 3. My third term I'm going to get by taking 3, multiplying it by 8, and then adding 11. 3 8s, 8, 16, 24, plus 11, 34, 35. So my third term is going to be 35. So work out my third term, it's going to be 35. Part B says, the order of the 3 terms is reversed to make a new sequence. Work out the term-to-term rule for this sequence. So rather than going -1, 3, 35, it's going 35, 3, -1. Now, what I had in this sequence above was a times by 8 and then plus 11 type function machine. Now if we want to go backwards, then we need to go through that machine in the reverse order then. So rather than adding 11 there, we'd be subtracting 11, and then rather than timesing by 8, we're going to be dividing by 8 to go back this way, aren't we? So it's going to be a subtract 11 divide by 8 function machine. Okay, so well, that's what we're going to write down. Subtract 11 divide by 8. Question 18. ABCD is a quadrilateral. Sides are extended as shown. Show that x is equal to 100. Okay, so we've got a partly completed diagram. We've got some angles given, but not all of them. And we need to find, or we need to show that that one over there is equal to 100. So we can't use the fact that it's 100. We need to arrive at the fact that it's 100. So how might we find that out? Okay, well first off, let's have a look over here where A is. I've got 2 lines that cross, and you should know that these 2 angles, which are called vertically opposite angles, are equal. So that means that that angle there must be the same as 70, so that must also be 70. Okay, so that angle is 70, and now we can work out what this angle is here. We can use the fact that ABCD is a quadrilateral. We were told that at the top, and that the sum of the angles in a quadrilateral add up to 360 to work out what that angle is there, that B angle. So we can say that this one in here is 360 minus those other 3 angles that make up the quadrilateral. So that's 70 plus 90 plus 120, all taken away from 360. Well, those 3 angles given add up to 70 and 90 is 160 plus 120 is 280, isn't it? So those 3 angles add up to 280. And 360 subtract 280 is 80, isn't it? So that one is 80. And then finally, we've got 2 angles on a straight line, haven't we? 2 angles on a straight line, and we should know that those 2 angles add up to 180. So then finally, x is going to be 180 subtract 80, giving me x is 100 degrees. Now this is a show that question, which means that you need to show a clear argument about why that is the case. But your argument doesn't have to be like an essay. It doesn't have to be you writing lots of facts down. Looking at the diagram and working on the diagram is perfectly acceptable. So I've worked out that 70 is equal to 70 then. I've shown it on the diagram. I've shown on the diagram that my other angle of the missed angle of the quadrilateral is 80. That's very nice and clear on the diagram how I've done it. And then finally I've shown that x and my 80 must be 180 degrees, making x 100. So I think that is more than sufficient at showing that that angle is 100 degrees. Question 19. Use 2 gallons equals 9 litres to convert 17 gallons into litres. Now, I can write gallons to litres as a ratio. So 2 gallons we said was equivalent to 9 litres. So what we want is to turn that 2 into 17. Okay. So how are we going to do that? We can try using the unitary method. We can say, well, if 2 gallons is 9 litres, then 1 gallon I can get by dividing that by 2, and dividing 9 by 2, I'm going to get 4.5, aren't I? So 1 litre is equivalent to 4.5 litres. So then if I then want to work out what 17 gallons are, I can times that by 17. So times in 4.5 by 17, what do I get? How do you do your multiplication? Different ways of doing multiplication. I quite like Napier's bones as a method of multiplying. So 17 and 4.5 that way. So 1 4s are 4, 7 4s are 28, 1 5 is 5, and 7 5s are 35. Adding up along the diagonals. 5, 8, 3, and 5 make 16. Carry 1, so 2, 4, and 1 makes 7. So that comes out to be 765. 765. But I had a decimal point there, so I'm going to have a decimal point here. So that comes out to be 76.5. 76.5 litres. You might multiply differently. You just need to have a method that works for you for this exam. Question 20. N is an odd number, P is a prime number. In each part, write down possible values of N and P so that, and first off we need to know or find values of N and P which add together to give you a square number. Okay, let's first off list a number of possible candidates for N and P. Okay, so N is an odd number, so it could be like 1 or 3 or 5 or 7 or 9, couldn't it? And we're told P is prime, so P could be 2 and 3 or 5 or 7 or 11, couldn't it? Okay, so there are some possible values. Hopefully that's enough. So can I find a pair of those N's and P's that add up to a square number? Well, my square numbers are 1, 4, 9, 16, and so on. Can I make one of those out of two of those numbers then? Just glancing through, I can see I've got 9 and 7. So 9 plus 7 is 16, so that works, doesn't it? So my N value can be 9. 9 is odd, and 7 is prime, so 9 plus 7 is 16, which is a square number. Secondly, you want to find two numbers N and P, so when I multiply them together I get a square number. So again, looking through my list, well, if I pick two numbers that are the same, that will give me a square number, won't it? So if I picked 7 and 7, 7 times 7 is 49, that's going to be a square number, isn't it? So N is odd and 7 is prime, so 7 times 7 is 49. So if N is 7 and P is 7, then we get a square number. Now there are obviously other pairs available there. Could have had 5 and 5 and 3 and 3. They would just work just as well. So I'm not saying that's the only solution. You might have come up with a different pair of numbers, and similarly for 20A there are other possible answers too. But they're the answers that I've come up with. Question 21A. Joe wants to bisect angle BCD. Here is his method. Use a pair of compasses to draw arcs of the same radius from B and D. Okay, so, oh, that isn't going to work. Draw a straight line through the point C. So he's put the compass here and drawn an arc, and then he's put the compass here and drawn an arc, and unsurprisingly has not managed to correctly bisect the angle. So what was his error? Well, what you're meant to do is you're first meant to put the compass at C and draw an arc that crosses both lines, and then use those 2 points to then go on to do your 2 arcs. Okay, so that's where he went wrong, isn't it? So how can I write that down? So he first needs to place his compass point at C and draw an arc cutting BC and DC. 21b, K wants to show all the points 3 kilometers from the point P, where 1 centimeter represents 1 kilometer. Here is her answer. Now she's drawn a square around P, and what's wrong with that answer? Well, what she needed to do was not draw a square, was it? She should have drawn a circle with radius 3 centimeters, and then all those points on that line would have been the locus she was looking for. So it's not a square, it should be a circle. So she should have drawn a circle radius 3 centimeters from P. 21c, here's a rectangle, and we need to, using a pair of compasses and a straight edge, construct one line of symmetry. Show clearly your construction arcs. Okay, so we're told it's a rectangle, and you should know then that the lines of symmetry of a rectangle go like that or like that. So if we can take this line here and we can construct a perpendicular bisector, then that line should be one of my lines of symmetry. So that's what I'm going to try and do. I'm going to use my compasses now to construct that line of symmetry. So it's a good idea to keep a little pencil, especially for your compass, which is nice and small, won't bump into your hands when you turn it. Make sure the tip of the pencil and the tip of the compass are in the same place, and then place the point of the compass on one end of the line. Make sure the gap between the two is a little bit over halfway, and draw your first arc. Okay, switch into the other end of the line and not move in the aperture of the compass. Draw a second arc. You should find it crosses in 2 places. Okay, that is the 2 points you're going to use to construct your perpendicular bisector. So place in the ruler so it goes through each of those points. Sorry, it's a little bit faint here. You should find that that line cuts your line exactly in half at 90 degrees. So that will be our line of symmetry for the rectangle. We're given that the ratio of x to y is 7:4 and that x plus y is at 88, and we need to work out the value of x minus y. Okay, so now this is well, if I rewrite this, x to y, or the ratio of x to y is 7:4. If I write that as an equation, I can say that y then is equal to, well, take x, I can get y if I divide it by 7 and times it by 4. So 4/7 of x, y is 4/7 of x. So now I've got 2 equations in 2 unknowns, y and x, so I should be able to solve those simultaneously. Now, normally when I solve simultaneously, I've got a couple of types of methods. There's elimination and there is substitution. Now, normally if you've got something that easily eliminates, where you can just see that you've got multiples of one or the other, then you can just subtract them. But here I think it's easier to substitute. Just talking waffle. Let's just say that again. Now you've got two different methods for solving simultaneous equations, either by elimination or by substitution. This one lends itself more to solving by substitution, so that's the method that I'm going to pick. So I'm going to call this one here equation 1 and this one equation 2, and I am going to substitute. Oops, no, I'm not going to write in that weird pen. I'm going to substitute equation 1 into equation 2. So that gives me x plus y. Now I know from the other equation that y is equal to 4 lots of x over 7. So x plus 4 lots of x over 7 is equal to 88. Okay, so how many x's have I got? If I've got x plus 4/7 of x, x is 7/7 of x. So 7/7 of x plus 4/7 of x is 11/7 of x. So 11x over 7 is equal to 88. So then dividing through by 11. So dividing through by 11 and timesing through by 7 should give me x. So then x is equal to 88 divided by 11 is 8, and times by 7 is 56. So x is 56. Okay, so I know that x is 56, and I know that x plus y is 88. So y must be equal to 88 take away 56, which is 32. Okay, so now I know x and y. I can now work out what the value of x minus y is. So therefore, x minus y then is going to be my value of x, 56, take away my value of y, which is 32, and that gives me 24. Question 23. Anil's home is 1 kilometer from a shop. He walked from home to the shop at a constant speed in 10 minutes. He stayed at the shop for 5 minutes. He walked home at a constant speed in 8 minutes. Anil drew the distance time graph to represent this journey. Here's the graph. Make 2 criticisms of the graph. Okay, well, first off, we're told that he walked from home to shop at a constant speed. So a constant speed should be a straight line on a distance time graph, where we've got a curved section here. They don't go together. It should have been a straight line from there to there, not a curved line. So it should be like that. Okay, so that's one criticism. He stayed at the shop for 5 minutes. Yeah, that's okay. And he walked home at a constant speed. Okay, and now the other thing is here, if he's walking home, that the distance from home is going to get less rather than more. So it should be sloping down at this point. Okay, so it should be a straight line going downwards, not upwards. So they're my 2 criticisms. So criticism 1, during the first 10 minutes, what's this guy's name? Anil. Anil is walking at constant speed, so the line should be a straight line. Okay, so that's my first criticism. And then my second criticism is that the line should be going down and not up at the end. So in the last 10 minutes, the distance from home should be decreasing and not increasing. Okay, so there are my two reasons. Three whole numbers are each rounded to the nearest 10. The sum of the rounded numbers is 70. Work out the maximum possible sum of the original three numbers. And that's quite a confusing question, really. I think sometimes if it's not clear how to proceed, then perhaps let's just try and do some numerical answers and see if we can work out what patterns there are or what the underlining things are. So let's have a look. So three whole numbers are each rounded to the nearest 10 and they sum to 70. So let's say that my three numbers rounded are 40, 20 and 10. That would add up to 70, wouldn't it? Okay, so what is the maximum number then that would round to 40? Now remember, these are whole numbers, so they can't be like point anything. So the biggest number that rounds to 40 is going to be 44, isn't it? Because 45 would round up to 50. Similarly, 24, so the largest number that rounds to 20 is going to be 24, and the largest number that rounds to 10 is going to be 14. So if you add those up, you're going to get what? 4, 8, 12 more than 70. It's going to be 82. Okay, so that's one possibility. So let's just have another look at a different one. So perhaps instead of having numbers that rounded to 40, 20 and 10, we had a number that rounded to 30 and then two numbers that rounded to 20. Does that change anything? So that adds up to 70 again. So the largest number that rounds to 30 is going to be 34. The largest number that rounds to 20 is going to be 24, and the largest number that rounds to 20 is going to be 24. So again, that's like 4, 8, 12 more than 70, isn't it? So I think whatever combination of numbers that you pick that round to your original 70, your maximum possible number is always going to be 4 more than that 3 times. So 4 times 3, 12 more than that amount. So the maximum possible sum has to be 82. Make sense? Circle the expression for the range of n consecutive numbers. Okay, so first off, what does range mean? Range means highest minus lowest, doesn't it? So range equals highest value minus the lowest value. Okay, now let's consider our n consecutive numbers. Now we don't know what the first number is, so let's call it a. Now my next number is going to be one more than that because these numbers are consecutive, so I'm going to have a plus 1. Then I'm going to have a plus 2, and then so on. Now what's my last number going to be? Now it's not going to be a plus n, because that means I would have n plus 1 numbers, so it's got to be a plus n minus 1, giving me n numbers altogether. Okay, so then if I take my highest number, a plus n minus 1, and take away my lowest number, a, then my range is going to be a plus n minus 1 take away a, which is n minus 1. So it's that one there. 3 identical isosceles triangles are joined to make this trapezium. Each triangle has a base of b and a perpendicular height of h. Work out an expression in terms of b and h for the area of the trapezium and give your answer in its simplest form. Okay, so first off, we know that these are 3 similar triangles. So if the baseline of that middle triangle is b, then this also has to be b, and this also has to be b. So that's quite helpful, because then if this is from b to here, we know that this must be 2b from here to here. Now the formula for the area of a trapezium is given by half a plus b h, where a and b are the 2 parallel sides and h is the perpendicular distance between them. Now in this particular case, my a is going to be b and my b is going to be 2b. So I'm going to have b plus 2b. There's my two parallel sides, and my h is still h there. Okay, so just to make that very clear, my a is going to be this one up here, which in this case is b. My b of my formula is going to be this one here, it's my second parallel line, and my h is just a h. Okay, so there's that one there. So just subbing those things in, I've got half b plus 2b times h. Okay, so b plus 2b is 3b, so that's half of 3b times h. And I can just rewrite that as 3 over 2 bh. There's a kind of simpler way of writing that down. B, this diagram shows the same trapezium, and now we're told that this side here is S, and that the ratio of B to S is 2 to 3. And now we need to work out the perimeter of the shape in terms of just B. So we need to express S in terms of B, basically. So if B to S is 2 to 3, then S is going to be, well, you're going to take B and you're going to divide it by 2 and times it by 3. So it's going to be 3B over 2. Okay, so S is 3B over 2. So if that's 3b over 2, that's b. So for along here was 2b, wasn't it, from before? And then up here is going to be 3b over 2 again. So adding those four sides together is going to give me the perimeter. So my perimeter is going to be my top line b, b plus my s, which we, plus my s, which we worked out to be 3b over 2, plus the baseline, which is 2b, plus the other slanty line, which is another 3b over 2. Okay, now 3b over 2 plus 3b over 2, so they're two halves of the same thing, aren't they? So that's going to give me 3b. So 3b plus 2b plus b is going to give me 6b altogether. So p is equal to 6b. 6b centimeters. And here is a quarter circle of radius 6 centimeters. Work out the area of the quarter circle and give your answers in terms of pi. Okay, so you probably remember the formula for circumference and area of a circle. If you're struggling with it, cherry, pie, delicious, apple, pies are 2. Handy way of remembering it. So here we want area, don't we? So it's this formula that we're after. We don't have a whole circle, got a quarter of one. So then the area of this quarter circle is going to be a quarter of pi r squared, where r is the radius, r is 6, so that goes in there. So my area is going to be 1/4 of pi times 6 squared. 6 squared is 36, so that is equal to 1/4 of pi times 36, and 1/4 of 36 is 9. So the answer is 9 pi. Question 28a, write in standard form 12,500. Okay, well, when we write something in standard form, we use the same digits. So I'm going to use the digits 1, 2, 5. But I'm going to put the decimal point there between the 1 and the 2. So the mantissa part, or the number part, has to be a number between 1 and 10. And then we're going to be multiplying through by the power of 10 that makes those two numbers the same. So 1.25, I would have to multiply by 10 to the power of 1, 2, 3, 4, by 10 to the power of 4 in order to take it back up to 12,500. So my answer is 1.25 times 10 to the 4. Right, now to write down as an ordinary number 3.4 times 10 to the minus 2. Again, my digit parts are going to be the same, but I'm going to be moving 2 decimal points this way. So filling in the zeros, it's going to be 0.034. Let's just write that in blue. 0.034 for that. Okay, done. Work out the value of the square root of 3 squared times the square root of 2 squared. Okay. Now you'll realize that square rooting and squaring are opposite operations. So square rooting something and then squaring it again will give you back what you started. So the square root of 3 then squared is going to just be 3, and the square root of 2 squared is going to be 2. So the answer is 3 times 2, which is 6. So very easy. 4 candidates in an election are A, B, C, and D. The pie chart shows the proportion of votes for each candidate. Now you can see in the pie chart that most of those have been given algebraically. This one here is a right angle, so we must know it's 90. And the other 3 are algebraic. So I think the first thing we need to do really here is work out what x is. So we know that those 3 angles there must add up to 360. So let's form a linear equation and x that we can solve. So our 4 angles, which are 90 plus our x plus the 2x plus 10 plus the 2x, that's got to add up to 360 degrees because there are 360 degrees in the circle. So collecting like terms, I've got an x, a 2x, and a 2x, which adds up to 5x. And I've got a 90 and a 10, which adds up to 100. So 5x plus 100 is 360. Okay, then change sides on that 100. Move it over to the other side. I'm going to get 5x equals 360 take away 100, which is 5x is equal to 260. And then finally I can cross multiply by that 5. So x equals 260 divided by 5, which is, well, dividing by 5 is like dividing by 10 and doubling. So 260 divided by 10 is 26, times 2 is 52. So x is 52 degrees. Okay, so now I know that, I can now answer the question, work out the probability that a person who voted, chosen at random, voted for C. So probability, you will remember, is equal to successful outcomes divided by total outcomes. Now in this case, successful outcomes is for C, isn't it? 2x plus 10. So 2x plus 10 over total outcomes is everybody. That's 360 degrees. Remember, these are in degrees at the moment. So I know now that x is 52. So that is going to be equal to 52 times 2 is 104 plus 10 is 114 divided by 360. Now that probably cancels down, but this is a non-calculated paper, so I can't chuck it in there, and it's a probability question and never give you marks for cancelling these down. So you might as well just leave it like that, 114 over 360. Factorize x squared minus 100. Now you should spot immediately that this is the difference of 2 squares. It's a very well known type of quadratic, crops up a lot. So I already know what this is going to look like. It's going to be 2 brackets like this, and x squared, the square root of x squared is x, so I'm going to have an x here and here. The square root of 100 is 10, so I'm going to have a 10 here, oops, here and here. And then I'm going to have a plus in that one and a minus in that one. This is called the difference of 2 squares, and it always comes out like this. Okay, you just need to remember this identity really. A squared minus b squared is equal to a plus b. A minus b comes up a lot, so it's an identity, so it's got 3 equal signs in there. Yeah, so remember that and you can't go wrong with these. B, solve 7x plus 6 is greater than 1 plus 2x. Now this is a linear inequality with unknowns on both sides. You can work these out pretty much the same way as you'd solve an equation, collecting the x's on one side and the numbers on the other. As long as you don't divide through anything negative, that should work fine. So I'm going to take this plus 2 and move it over here, and I'm going to take this plus 6 and I'm going to move it over here. So it works the same way as equations. If you change sides, you change signs. So my 7x, if I take the 2x over, it will become minus 2x, and that's going to be greater than 1, which was already there, and I'm moving the plus 6 over, it's going to become minus 6. So 7x minus 2x is greater than 1 minus 6. 7x minus 2x is 5x. That is greater than 1 minus 6 is minus 5. And then dividing both sides by 5, I'm going to get x is greater than negative 1. Okay. Just take care with inequalities. You avoid trying to divide through by negative numbers, and you should be fine. Okay, so x is greater than minus 1 is the solution. So that's all. We've reached the end of the paper. How did you do? Let me know in the comments below, along with any questions you still might have. Don't forget to like and subscribe if you found this walkthrough helpful. If you didn't do so well, try revising around the topics you're struggling with before attempting another past paper. Good luck with your preparations and in your exams, and see you again next time.